You're all very welcome here to another NSBarcelona event. Thank you for coming. It's always great to have a community event, even though the last one was only 2 weeks ago. It's good to see you again. And we actually don't have another one coming for next month. So if you can ask anyone in your company, so please, somebody volunteer because we have a gap coming up. We don't plan to have any event for July and August because everybody's away. So then the following one would be in September. So if we can fit one in just before the summer break, it would be great. But anyway, so thank you very much to Glovo for hosting us. Once again, the last time we were at Glovo was in a different office 1 year ago, where I gave a talk about Twist, if some people remember. But anyway, today we have a special guest from Manchester, but he's not really from Manchester. He's from here, actually. So will you give a nice welcome to, a warm welcome to Paul, please? Thank you.
Cool. Thanks everyone, and welcome to my talk on delightful Swift CLI apps. So before I kick off, yeah, it's working. Before I kick off, I want to quickly introduce myself. My name is Paul. I'm a senior software engineer at the BBC in the UK. I write weekly articles on my blog at paulpillay.dev. I am also the curator of a newsletter called the iOS CI newsletter, which you might or might not know. I am based in Manchester in the UK. I've been based in the UK for nearly 10 years, which is pretty scary. But I am originally from Barcelona here in Spain. So yeah, super happy to give finally a talk in my hometown, which is pretty good. And yeah, for the last few years, I have been advocating for using Swift to write tools. And the reason I've been advocating for it so much, apart from Swift being a great language, is that if you're an iOS developer and you're building tools for iOS applications, or you're targeting Swift developers, then it makes a lot of sense to write them with Swift as well, because it's a familiar language for all of us, and it's something that we're confident with, and it's going to help you maintain tools in the future as well. On top of this, Swift has some pretty cool features. It's got a very low memory footprint, which means that when you run an application, it doesn't require a lot of memory, as opposed to other, memory-hungry languages like Java. It also has type safety, so you get a lot of errors and warnings at compile time that with other languages you would see as runtime crashes or exceptions. So it makes the feedback loop a lot quicker, and it makes developing safe applications a lot better. And now with modern concurrency and a lot of the distributed actors and memory systems, you're going to build safe, not only type safe programs, but memory safe programs. It's very, very easy to make them. It's also got a very mature ecosystem, and it's got a great open source community behind it as well, which means that it no longer is only an Apple app development platform. You can actually build for multiple platforms. You can make scripts, you can make server-side applications, and you can make command line applications that not only run on macOS, but they also will run on Linux, and they can also run on Windows as well, which is pretty exciting. Cool. And for me, one of the main advantages of using Swift, if you're building a macOS tool that's for, a command line application that's for macOS, you can very quickly expand it in the future if your use case grows to be a macOS application, right? So you can use a Swift UI view, you can wrap it in an app, and you can launch it from the command line. So you can literally keep your call side the same. Your users will still use the command line, but you can launch a macOS application. And a great example of this is Marin Todorov's Time UI tool, which I think is great. And yeah, it launches a Swift UI application from the terminal. Or it's taken a while to change slides. Cool. And there are obviously some great examples of Swift CLIs. All of these examples that appear on the list are projects that are built entirely with Swift, and their command line interfaces and their command line applications are also built with Swift. So this is a great example of tools that are actually, they've built their tooling with Swift as well. So an example is Sorcery. Some of you might have used Sorcery in the past. It's a code generation package, and it's kind of like aims at Swift meta programming. So you can define a lot of templates. So you don't actually have to code boilerplate or add boilerplate code all the time manually. You also have SwiftLin, which links Swift code and makes sure that your code meets some shared standards across your app. You've also got Twist as well, which is a Swift project to create and scaffold iOS and macOS applications and modular projects. And its logic is completely built with Swift, but the CLI toolbox and the application as well is built with Swift as well. You've got SwiftGen as well, which is also similar to Sorcery, and it's a code generation library. And if we jump over the fence and we go to the web ecosystem and server-side ecosystem, you've got Publish. I don't know if you've heard of Publish, but it's a static site generation targeted at content creators. So basically, if you've got a blog and you write articles with Markdown, you can generate static HTML using Publish. John Sandell, his website, Swift with Sandell, is built with Publish, and the CLI and the whole framework is built with Swift as well. And on the server-side side of things, you can build server-side Swift applications using Vapor, which is an open source framework, and the toolbox. So whenever you do a Vapor init on the command line, that's also built with Swift. So this is a great example. If you've got an open source project, if you're a maintainer of a library or open source, which targets iOS developers or targets Swift developers on the server as well, it's a no-brainer to make your tooling with Swift, because it's going to be a lot easier for you to find maintainers. It's going to be a lot easier for people to contribute to your tooling as well, because they don't really have to learn a language. They can literally just jump in with Swift, and they have to understand the system, not have to learn a new language. Awesome. And for me, one of the best improvements in the past few years is the introduction of the Swift Argument Parser library by Apple, which allows you to use Swift native features to read arguments and read input from the command line. And the way it works is you provide a bunch using property wrappers that Argument Parser provides. You declare what you want your user to provide. So you can declare flags, options, arguments, and then it will do all the validation for you, and it will be type safe. You can provide default values just as declaring Swift variables, and it will do all the validation and handling of input from the command line for you, which is, yeah, it's a no-brainer. If you're writing a command line application, use Argument Parser. And it also gives you modern concurrency by default. So it gives you structured concurrency, so you can use async await. And this is kind of like catching up to ecosystems like JavaScript, which have kind of always allowed you to use async await to build command line applications. Now Swift allows you to do that. So it kind of like bridges that gap as well and makes the entry barrier a lot lower. And this is an example of what you get for free by defining these property wrappers and providing help strings on the terminal. If the user misses any of the parameters that you require, you will get that help for free. And you also get the -- help command that you get in command line tools. That's also for free with Argument Parser. So the ecosystem is absolutely fantastic. You can build so many things. And yeah, as I said before, you can actually build your executables and make them run on Linux. So you could build a tool. And for example, we all know that GitHub Actions hosted runners are very, very expensive on macOS. So you could have a tool, cross-compile it to Linux, and save you a lot of money on CI/CD as well. And you can build it with Swift as well. You can just compile it to Linux. And this is thanks to the open source community. So Swift, I can't remember when it got introduced, but it supports cross-compilation from macOS in Swift packages. And Keith Smiley, I don't know if you know him, but he's got a pretty big online presence and makes a lot of awesome open source projects. He made the Swift PM Linux cross executable that you can download. You give it a Swift version, you give it a Linux operating system and version that you want to target, and it will generate a bunch of like destination files. It will download the tool chains, and it will also give you a Swift package command, Swift build command that you can just run on your Swift package, and it will just generate an output for you. And I actually was in a conference a few weeks ago, and I saw Tim Condon, one of the core maintainers of Vapor, speak about server-side Swift and the state of server-side Swift. And he introduced Swiftly. So Swiftly is a new command line tool that the server-side work group are working on, and it will allow you, I don't know if anyone's used Rust here, but Rust has a Rust up toolchain that allows you to command line tool that allows you to install tool chains, delete them, manage them. So Swiftly aims to do the same for Swift. So if you're familiar with SwiftEnv to install tool chains, this is very, very similar. At the moment, it only runs on Linux, but I believe there's going to be support for more platforms further along the line. And one last thing about command line tools is that you can also automate your releases. So I wrote an article recently about how I automate the releases of my command line applications. And if you build your CI/CD in a way that you can just deploy it to Homebrew, you can deploy it to GitHub releases and have like automatically generate artifacts and distribute them to your users, you can build an incredible ecosystem where you can ship your tools very, very easy. And it becomes a breeze to make any kind of tooling with Swift. And I've probably talked way too much about what's great about Swift, but there is something that I feel like the Swift ecosystem for tooling and for making great command line tools is missing. And this thing is that making tooling that actually looks great on the CI and it feels delightful to use is actually very hard. And the reason why it's hard is because I feel like the UX developer experience is actually not that great. Other languages and ecosystems are a lot more advanced at this. And a great example of this is JavaScript. So JavaScript is a great example. They've got a ton of libraries that you can use, and they give you interactive components. They give you loading spinners, like a bunch of things that you can add to your command line tools and make them more interactive and feel more, delightful to use. And I feel like that's the word I keep repeating, but I feel like that's what we need to aim for when we make our tooling. So when you are distributing something to your users, when you're making your apps, you try to make them delightful, you try to make them look very nice. And I feel like with tooling and with command line applications, it should probably be the same. Like we should aim to make things as smooth as possible and make them as nice as we possibly can. And I am now going to play an example of a tool that quite frustrated me at the beginning, and it's Swift package init. So that command, whenever I run it, coming from other ecosystems and context switching a lot, I never used to remember where it created, whether it created a new directory or whether it created all the files in source. So we go to my developer directory, call Swift package init, and then it will have created a bunch of files that I need to go and delete. So then the process I follow is I create a new directory, and then I cd into it, and I do Swift package init to create a new Swift package. But the problem with this, though, is that I like to name my directories with a kebab case, right? So I like to put a dash the same way I name my repos on GitHub. But that doesn't play very well with Swift package init. So when you do Swift package init, the targets will then become kebab case, and you see the underscores in the files as well. I would like that to be Pascal case. The thing is, you can actually pass a dash name to the Swift package init command to change the name so that it doesn't grab the directory name, but that's not really obvious. And at this point, I probably wanted to create an executable as well. And you need to pass a dash executable flag to the command, otherwise it will create by default, it will create a library. So yeah, then you have to go in, you have to modify the targets, and you need to do a bunch of stuff to get you started. And I'm going to show you now a polar opposite, right? So I don't know if anyone's done any web development here, but one framework that I really like and I've been using recently to build my blog is Astro. So Astro's command line tool is one of the best experiences I've ever had. It looks amazing. So when you do npm create Astro latest, it's got all these like cute animations. It tells you, it asks you where you want to create your project, what name you want to give it, whether you want to use a template. So you can imagine Swift packaging, it could be like this, right? It could be, where do you want to create it? What name do you want to give it? Should it be an executable? It tells you whether you want to install your dependencies, whether you want to write TypeScript. It could kind of like ask you if you want to, add a linter to it or something like that. And recently, actually, I added this slide this morning because I saw a tweet from yesterday or today, I can't remember. Cloudflare is also using things like this. So when you do a Cloudflare create to build a server-side framework, you also get like all these nice like interfaces. You've got loading spinners as well while it's installing dependencies. So yeah, there's a lot of room for improvement. I feel like there's not a lot of libraries in Swift that allow you to do this. And the thing that makes JavaScript such a great language to develop CLIs for in terms of UX is that the ecosystem allows for delightful. So there's a library called Dora, which gives you like nice loading spinners on the command line. There's Chalk, which lets you change the color of text in the terminal, provide like background text as well. You've got prompts. So prompts by default give you interactive UI components for the terminal. I think someone actually made a project that allows you to create React components for your terminal, which is pretty crazy. But yeah, you've got Commander as well, which is similar to Swift argument parser. So you can create commands and stuff like that. And you've got my favorite, which is Clack. So Clack is an open source project that Astro, don't know if they're used, but it's from one of the core maintainers of Astro. And it allows you to kind of create a form on the terminal. It gives you a ton of interactive UI components. So it gives you text fields, gives you selects, multi-selects, pickers. So yeah, it's a delight to kind of like make applications with this kind of tools. And Swift does have some tools like that. Some of them are migrated directly from JavaScript, like Chalk and Commander. You've got TermKit and ANSI terminal as well, which kind of allows you to do like low-level commands and change the color of text and do that kind of thing. So Swift does have some tools like that, but the thing that I'm missing is a library that actually gives you, UI components out of the box that you can use, and you can make like interactivity very, very easy. So I decided to go down a very, very deep rabbit hole and look into how these tools work and see if I could like kind of make my own in Swift. And the thing that I found is that they work under a very, very, very simple principle, which is ANSI escape sequences. So ANSI escape sequences are just strings of characters. So they're just sequences that allow you to perform operations on the terminal. And this can be changing the color of the text, providing a background color, or even changing the cursor position on the terminal as well. So they've got a lot of control. And they're supported by Unix operating systems. What this means is that any modern terminal that you run on your macOS or Linux will have support for these sequences. And you've got support for it from Windows 10. So yeah, from Windows 10 onwards, you've got support, I believe, for Unix, for ANSI escape sequences as well. So if you're wild enough to go and develop a Swift CLI for Windows and you want to go through the pain, you're gonna need to be aware of this limitation. So how do ANSI escape sequences work? So ANSI, let's see an example of modifying text to change their color. So if you print hello world on the terminal, let's picture that the thing on the right-hand side is actually a terminal. It will print it with the default color that you've got set up on your terminal. If you want to change this color, the thing you need to do is you need to tag on some special characters onto your terminal. And this will be comprised of a start sequence, which will be a Unicode sequence. And then you've got the command. So the command will be a square bracket, and then the command you want to execute. So what I'm telling it here is 31M is the red color. So I wanted to change the color of anything after this command to red. So you'll see the output has changed to red. I can also like chain these commands. So I can provide a bold command. So I can change the font weight of the text to bold. And by now you're thinking, what is this mad person doing, showing me the weird strings and like things like that? And if you're actually wanting to do some text fields or interactive placeholders and stuff like that, you don't really want to be messing with strings because you probably lose your head before you actually get to do something cool. So I found a library that's pretty great, and it's called ANSI terminal, and it abstracts all this logic for you, and it gives you Swift commands. So it gives you methods and it gives you extensions on string so that you can perform all these operations in a Swifty way from your Swift packages. So how does this work? So let's say you've imported the dependency into your Swift package containing your executable. You then import the library. So you import ANSI terminal. And then inside your print statement, you can just use string extensions that ANSI terminal provides. So instead of going crazy with like string manipulation, you can just say you want your string to be .red. And it literally just returns a string. So you can just stack it onto your string on your print statement, and it will just work out the box. You can change them as well because each extension returns a string. So I can say I want it to be red and bold. So I can just say .red, .bold. Very simple. Like it's super easy to use. But I wanna, like, this is not that useful really. So I wanna like turn it up a notch, and I'm gonna show you how you can actually modify the cursor position. So by default, Swift prints statements in a new line and then moves the cursor over to a new line. So you can actually override this behavior by changing the ending operator of the print statement to something else. So you can change it from a new line to something else, or you can use ANSI terminal. So ANSI terminal has a write command and it has a write new line command. So if you use write, it will just move the cursor to after the text. But what you can do is you can find out what the cursor position was before you wrote, and then you can actually do some manipulation to that will print, that will give you that position in the text. So it will give you before it printed. And then you can actually use another ANSI terminal command called move to, and you can move it to the beginning of the text. So yeah, you might be thinking now, why on earth would I do that? But it could make for like very, very cool things. So this is the principle of a placeholder, right? So you kind of have some text and you're still at the beginning so the user can type. So let's say you wrote and you changed the color to another color. So you made it a bit dimmer, right? You dimmed the color of the text a bit. And then you can mimic the user typing by adding the word hello. So that's kind of like behaving like a placeholder, like we saw before in the Astro command line. So yeah, you can achieve very cool things with this, but you have to be aware of one limitation. The console on Xcode is not a Unix terminal, and ANSI escape sequences are only supported on Unix terminal. So if you run something that uses ANSI escape sequences, you'll see something like this, a lot of nonsense like characters all over the place. So yeah, I would thoroughly recommend to use a proper terminal. And it's not your fault. I've spent way too much time trying to figure out what was going on here, why my escape sequences weren't working. It's not your fault, as someone somewhere said probably all the time. It's definitely not you. It's Xcode. It's not a Unix terminal. Keep that in mind. And your terminal is your best friend. So yeah, make sure you run it with Swift run, or you do Xcode build run as well if you've got an Xcode project. So you can actually run your command line from the terminal if you're using this kind of thing. So now that I've actually explained how these libraries usually work, I'm going to talk about something that I've been working on recently. So I've been trying to migrate the library that I talked about at the beginning, Clack, which is a JavaScript project. I've been slowly, actually very, very slowly, because I've not had a lot of time. I've been migrating it to Swift. And the library gives you a lot of interactivity. So it gives you pickers, it gives you text fields with placeholders as well. So I've been starting to migrate it to Swift. And it's completely open source. So I've been doing it in public as much as I can. And today I'm going to show you how I build the text part, so the text input of the library, and how you can use it in your command lines. So I decided to roll with my custom text entry, and I'll explain why now. The reason why I wanted to do this is because I wanted to add a placeholder. So you can see in the enter your Open API key token, there's a small dim text showing the start of an Open API key token. So yeah, that's kind of the placeholder I wanted to do, and I couldn't do it with the default read input from Swift, so I had to do my own logic. Another thing I wanted to do is validation. So whenever you hit enter, the string that you've entered is validated as well. So if it's an empty string, it will print a small comment at the bottom saying cannot be empty, and it will also change the state of the UI at the left-hand side. I also wanted to do support for secure text entry. So just you see those little blocks reducting the input as well. And this comes from one of my biggest frustrations with command lines. Whenever a command line tool asks you for a password, it usually just doesn't show what you're typing, which is very, very annoying. So you could be typing for half an hour and then you're not focused on that window and you don't even know that you've not typed. So when you hit enter, it tells you wrong password because you don't know really what you're typing. So I kind of wanted to do this so that you actually saw that you're typing something. And I've split it into two separate parts. So there's the headless component and then there's the UI. So you could bring your own UI and do your kind of thing and change the layout of this as well. So I'm going to start with the headless part. So the headless part, it's a very glorified component. It's literally just one function. This function has got two parameters for validation. So one of them is going to perform a validation. So you're going to pass it a string, and it's going to tell you whether it's valid or not. And if it is not valid, then it's going to call the validation failed closure to display some UI. Next step is what happens when the user types a character in. So whenever there's a new character, we want to update the UI with the new character. And whenever there's a delete, we want to notify the UI that something's been deleted, right? And we want to tell it which row and which column. So this means which line in your terminal and which character in that you want to delete. And then the next thing is we want to know when to show or remove the placeholder from the text field. And then the logic inside the function looks a bit like this. Very, very simple again. It's an output, which starts as an empty string, and then you iterate forever. So you keep a while loop open so that you can listen for user input. And this while loop will only end once the user breaks it somehow. So once the user ends it. So the first thing we do is clear the buffer. All of these methods that I'm going to use are from ANSI terminal, so you don't have to write your own. It's literally just all provided by the library. So you clear the buffer, you start listening for key presses. So you need to know if the key was pressed. And then if a key was pressed, then you read the character that was inputted. Very, very simple. And yeah, an ANSI terminal gives you that list of non-printable characters and printable characters. So you can actually check if the character was entered. So when the user hits the enter key, we want to perform the validation. And if the validation fails, then we want to call out that closure that we passed in as a parameter. Super simple. And then whenever the user presses the delete character, we want to check the cursor position, and we just want to move it one to the left so we can know what character to delete. And we remove the output variable that we created at the top. We just want to remove the last element because that's what the user is deleting. And then another cool thing is that if the output count is 0, so if there's nothing in the text field, we want to show a placeholder. And then whenever the user types in a character, so this is if it is a printable character, so this is the way you avoid arrow keys showing weird characters in the terminal as well. So if it is a printable character, if the output is empty, then we want to remove the placeholder. And otherwise, we just want to call out the closure and say, you know, there's been a new character and we want to add it to the string. So fairly simple, but there's no UI yet. So we want to add the head to the headless component that we've got. So to add the UI, we just call our method, literally, that's all we have to do, our headless method. We pass in some validation logic. And in this case, it's just going to check if the string is empty. So if the string is empty, it's not going to, you know, it's not going to exit the loop. And if the string is not empty, then it's going to validate and exit the loop once the user hits enter. And then we've got a validation failed parameter as well. So we need to do something when the validation fails. We set some state in our component. So we say that the validation did fail. And there is a lot of method calls here. All of these methods are from ANSI terminal. But all you need to know is that I'm just moving to different positions in the terminal, and I'm just updating certain things. So all you need to know is I'm updating the left bracket on the text field to be another color. I'm updating a Unicode character as well. And I'm writing the failure string as well at the bottom of the text field. So I'm just moving about and writing characters. So nothing too special there. Whenever there's a new character, if the validation failed, I want to do the reverse of what I did. So I want to remove that failure string, and I want to remove the failure state, basically. So again, basically just moving about, writing characters and changing color and Unicode characters. And the cool thing is to do that the entry of obfuscation of adding those squares for the password is literally just a Unicode character. It's a ternary where I say, if it is a secure text entry, print this instead of the actual character. Otherwise, just print whatever the user has inputted. Which is, yeah, fairly simple. On delete, super easy. You just move to a position that the headless component has given you, and you just call delete character from ANSI terminal. And then to remove the placeholder, you just move to the bottom of the text field and clear the whole line. And then to show the placeholder, you move to the beginning of the text field, and then you write, basically. So it's super, super simple. You don't really have to do like a lot of magic. And within like 10, 20 lines of code, you've got a nice interactive component that you can work with. And yeah, that's literally it. So as I said, I'm just moving about and updating Unicode characters, and I'm updating their color, moving to the beginning of the text field to clear the placeholder and add the placeholder. So yeah, very, very simple. There's nothing too complicated about it. It's just like trial and error and playing around with the library as well. And definitely leverage the power of Unicode. This was something that was quite like daunting to me at the beginning. I always looked at this kind of libraries, and one that really stuck out to me was Aura, which is like that loading spinner that you see next to the text. It's a great way to like show your users that you're doing an asynchronous operation. And yeah, I always thought that it was quite complex, but that's the beauty of open source. You can actually just go and check what they're doing. And what I found out is that they're just using the Braille pattern characters. So they're using those Unicode characters and just rotating them. They're using different variations and states of the Braille pattern characters. So just be creative, and you can actually come up with some pretty cool solutions in no time, really. So yeah, if you want to take a look at the library that I've been making, it's all open source, so you can have a look at it. And I'm going to show you now very, very quickly how you can actually build a component and a CLI with this library. So I'm going to show you an example of a command line tool that I made. It's called Chatty. It's also open source, and it allows you to communicate with OpenAI, with ChatGPT directly from your terminal. And I needed a way for users to store a token in a secure way. So I kind of made this little flow using my Swift library, and I allowed them to copy paste into the text field or type it in themselves, and then it would just get stored to the keychain. So the way I did it was, again, make sure you use Swift argument parser because it will save you a lot of time reading input from the user. So I created a subcommand in my executable, and I used Clack Swift, my library, to use components basically. So I created an intro component from the library. Then I created a text component as well, the one we've just created. It's just wrapped in a text function. And I saved it to the keychain. This is just a library that I've used for a while. And then finally, I just use the outro, right? So that's the intro at the top, text in the middle, a text component, a text field, and then the outro at the bottom. And the way this looks in the terminal is like this, as you've just seen. And if we break it down component by component, the top bit is the intro. So you see how it's got the bracket at the top, denoting that it's the intro of the form. Then you've got the text component in the middle. And you can see that when it's been completed as well, it changes to like a tick as well. It's quite useful to see what you've completed. And then you've got the outro as well. And you can modify the text, you can modify what you're printing. So it's, yeah, super, super handy. And I wanted to make something for myself and for other people to just make tools that look nice and that feel nice to use, just very, very easy. Like you just grab the components, you just put them there. And because the last thing you want to do is like mess around with this while you're trying to make something very, very quickly. I just had the time to do it, to be honest, and I'm really interested in this kind of thing. And again, Chatty is completely open source. Sorry if there's any Madrid fans here. I put the slides before what happened last night. And I was asking, I'm a Barca fan. I was asking what's the best football team in Spain and why is it Barca? Which it couldn't answer. But yeah, sorry about that. But if you want to check out the library, it's completely open source. So yeah, make sure you head over to take a look. And yeah, thank you so much. I'm in too many places online now, I think, to kind of list them all in the screen. So I created like a little link tree thing that you can find me online if you want to reach out or chat to me. But yeah, thanks so much. If you've got any questions, just let me know.
So thank you very much. That was really cool.
Sorry?
It was really interesting. I'm going to definitely dig into that. But I have been digging into argument parser. And one of the things that really surprised me was how big the binary is when you include that library and it's all of its transitive libraries. It always gets to 11 megs for like 200 lines of code.
Yeah. Yeah, no, I completely agree. It can take a while to like clone all the dependencies as well. And it can take a while to build as well. Like you'd be surprised how long it actually takes to build. My recommendation, and it's something that we've been doing at work, if you are like wanting to run a tool on your CI/CD, or if you want to run a tool on your machines, I would suggest that you compile it ahead of time and you just put it in a directory or somewhere in your CI, or even like embed it in your runners so you can run it quickly, because otherwise you're going to spend a while just doing Swift run. I don't know if anyone uses Danger here on their CIs, but if you do, we saw a massive benefit from compiling it ahead of time and just embedding the binary, because it has to clone a ton of stuff and it takes a while to do the Swift run. So yeah, that's one of them. I don't know how big the binaries end up being, maybe quite big, but yeah.
Yeah, well, what we noticed when we added Swift, Danger Swift to the CI was, oh damn, we have to remove it.
Yeah, yeah. There is actually, I was chatting to someone to Antoine van der Lee. I don't know if anyone knows of him, but he told me that he was looking into it for WeTransfer, and I think their CI code is open source. So I think you can probably take a look at what they did and their PRs as well to do with Danger Swift, but they saw an improvement, and off the back of that, we did the same in iPlayer at the BBC, and we saw an improvement in build times as well. So yeah, compiling ahead of time and making the binary ahead of time is your best friend.
So there's one other thing, and so you're mentioning sorcery. Do you know that sorcery has, let's say, a younger brother? Yeah, I'm joking, of course, but so there's something called Swifty Mocky.
Oh yeah. I've seen that. Does that use sorcery under the hood?
It does.
Yeah.
Have you seen their CLI?
No, I haven't seen it.
It's really good.
Oh, nice. Nice. To build with Swift as well?
I didn't check.
Oh.
I didn't check. But the thing is that it actually is one of the best CLIs I've ever seen in a tool.
Amazing.
So
yeah, I've not seen it, but I will check it out tonight. Nice.
Right, that's it for me. So thank you very much.
Thank you.
A round of applause for Paul. Oh, yeah. Okay, cool. Pizzas are here. Anybody hungry? Anybody thirsty? We'll take a break and we'll resume after. Okay. I've been trying to get these parts. The thing there was that it's a code generator, but it gives you tools to set it all up. Generate your YAML file and so on, and you can set it up on a project. Then the code that it generates this is where I go with it. Teammates so it generates thousands of lines. It's like sorcery. So it's using sorcery, but it's the.
I've always found that with sorcery, all of the templates to generate mobs and stuff, they're too involved. Like that's what I always do.
But what Swifty Mock is doing is way more, and it's so much that I just like I can't figure it out. There's too much in there. But what they do have out of this though is a very nice syntax of given when then. That is really cool.
Like behavior.
Yeah, so it generates functions in that style and it's validating this code like that. But the amount, the cognitive overload I had in trying to figure out what it's doing.
Yeah.
I couldn't figure it out.
That's kind of like the main point of like this.
Hello, we are going to start the second talk now. Do you know which one he was using? Just take this.
Take the yellow one.
No, he took the yellow. Of course.
You got the pizza? Okay. Hello, everyone. I hope you enjoyed the pizza. My name is Lorenzo, and as you may see, I'm an iOS engineer at Glovo, and I work in the customer core team. And as you may guess by the name, I'm mainly working on the customer iOS application. But assuming here that you know Glovo, we got another application, the Courier app. But today I'm going to be telling you a story about the history of dependency injection at Glovo from the customer point of view. But before we start, people in Glovo got to know me, but a quick disclaimer. I tend to use a lot of emoji and GIF. So if you have any sickness about it, or if you feel a little bit off, just stop and consult a doctor. I don't know if we got any doctor or done, but and let me start by saying something about Glovo. Our company has an ambition vision to fulfill, and is to give everyone easy access to anything in their city. But why is ambitious? By checking the number, we operate in more than 20 countries with more than 1,300 cities, and we have around 130,000 partners. So a lot of numbers. We got quite a reach. And how we are contributing to this vision is roughly on customer iOS. We have half of our monthly active users are coming from our platform. We got a pretty high conversion rate in the company. So 55% of our users are ordering from the customer iOS application. And we got featured for 4 times in the App Store.
Other than this, from the inside, we are more than 30 iOS engineer. The PR merge were more than 1,000 in 2022. And we work in purely Swift, more than 600,000 line of code. Not just the customer iOS app, but even the repos that we touch, that we share with Courier. Having said that, I was saying, and I'm going to be telling you a story, and it's time for the story, no? And the first chapter is the lack of ADI system. Wherever we are used to start an application from the beginning, from scratch, we don't have a ADI system. And Apple doesn't recommend us to use one. Like on Android, for instance, they know that they need to use now Hilt. So they got a pretty huge community and standard from the company. So you may go wild. You may use a third party that you find out there. You may use your solution. You may inject manually by constructor. You can do a lot of things. And if you do things poorly, things may go really wild and wrong. But let's see how it goes for us. And everything started for us by creating organically 2 DI container, one for the so-called Glovo services and another one for the app services. The Glovo services are actually classes to make network requests, so for our endpoints. And the other one, the app services one, are anything that you can, that needs to be instantiated only once and leave for the whole life cycle for the application. And it can deal with third-party frameworks or Apple frameworks, anything to abstract those frameworks and needs to be used and injected everywhere in the application. But on top of those, we have been having a super nice syntactic sugar.default, where you can access directly to the instances of those 2 containers. And if you abuse about this convenient way of accessing those instances, you may have, a lot of issues. I don't know if you're excited or scared about this, but you may be a lot scared, no? And things at Glovo go pretty high speed, fast paced. So the app grew so fast and it was abused a little bit. So it was used directly without injecting. So you may have a session service in Glovo service. So if you type session service.default, you can access instantly to the instance in the container. But if you don't inject that one, you may have trouble, no? Especially in testing. But let me show you a little bit of chicha, meat, no? The Glovo service container, for instance, is actually a simple class. It has, of course, a log for thread safety, default to access directly to the single instance of the container. And as you already see, there are some services that you can see, of course, but the real number is roughly 40 services in here. And you already seen the impact. So we had to add a property wrapper test mockable to make sure that you cannot inject directly the mock for those in test, but you need to use a custom function instead. So this function was merely, yes, as another custom tooling that we built on top to make sure that even if you use the .default syntactic sugar, you can test your code. So you need to mock a service, and whatever you pass the mock for that service, and you need to run in that closure, you know that you're going to be getting the mock instead of the real instance, and then it's get back to normal. The issue with this is that aside from the impact you may have in testing, because you need to write those whatever you're not injecting, you may have the closure, let's call it closure hell, no? All those closure nested. So it's not that nice. So to conclude for this part is actually the injection. We started to inject those instances instead of using, of course, the .default at some point, making things better. But it wasn't really scalable for our modularization because meanwhile we are modularizing. And the thing is that you can be fine with this, but it's not a system. You still need to be injecting manually all the instances. So you need to maintain the order of in which you instantiate those instances. So we don't have a DI system. But then the second chapter is actually a work group time. But what is a work group in Glovo? And thanks, Paul, for mentioning work group. Actually, is a way of gathering, when we gather for a common goal, a common interest, we are empowered. So somebody, an individual contributor is a topic, in this case, improving the DI or modularizing in this way or doing some migration. And we gather interest with other iOS engineer. We go together with a common goal, empowered with decision-making. The work group can be long-living or short-living, depending on, like an example of long-living, maybe standardizing architecture for iOS at Glovo. So MVVM and such, though this one has to be long-living because the work group need to provide support for the whole life cycle of the company. Instead, the short-living may be migrating from quick nimble to XCTest, for instance. And you need to have a proactive experimentation mindset in the work group. So you need to experiment, and you need to, we're trying to enable knowledge share and teams grow, therefore mixing junior and senior within a work group and to have a little bit of fun. And once you do something, you brought it back to your team and you do a knowledge share. In this case, what we did was evaluating our option, like third-party DI system out there, at least the one we used to know and we used to work with. Swift inject, Swift dependencies from point free, clean Z, needle, and so on and so forth. Second option was we checked the existing solution built internally by the Courier folks. I mentioned before that we got another iOS application. They built already a dependency container, so-called, I'm going to be showing you in a minute. And they're using it in production. So, okay, cool. Another option was actually build our own DI system. So yet another DI system. Okay, so we got many options to choose from. Then, to make an objective decision and not one biased by your preferences, in general, in our group, we set a set of requirements. And in this case, we wanted this to be, the DI system to be compile time safe, easy to use, easy to adopt, and possibly setting a standard for the DI system in Glovo, in iOS. And given the last requirement, the first thing we did, okay, we got an internal solution, it's production ready, let's give it a check. So, as I said, internal solution by Courier, built by Courier. Production ready. And actually, this will foster the alignment we want. We can set a standard pretty easily if we love the solution, right? So let me show you the solution. They're using an abstraction for a resolver. So you can actually see you've got two simple functions for resolving a given a dependency given a type and an input. An input can be optional, of course. In the extension, you will see. But the resolver is actually a dependency container. So you may have a dependency container that is a concrete implementation for the resolver. Actually, you may have multiple dependency containers across your code base. The instances may be allocated either short and long living. So you may have factory, that means that needs to be recreated every time you resolve it, or unique. Therefore, it's a singleton. It's going to be created once, and then it's going to be long living for the whole life cycle. And then we got, of course, a log for thread safety. We store the allocator. The allocators are actually, it's an array for the function that are responsible for creating those instances, and an allocated array for actually allocating the one that we need to return. So the long living instances. And I'll skip the register and resolve because actually are simple, no? You need to register and you need to resolve. But in this case, it didn't meet all our requirements. So it is not compile time safe, unfortunately. So if you forget to register a dependency, it's going to be crashed at runtime. The thing is that we trust ourselves. We are responsible engineer, but we are human, so we can make mistake. So if we can catch it, the better. Second thing, it was doing a little bit more things that we actually need, like having the input. We weren't seeing the, a use case for us for the input, or having the input as well. And it wasn't that easy to adopt for some of us. Like we see this traceability issue with the registration. So you may register in various dependency container all around the application, and you will not understand where these dependencies is coming from. So unfortunately, it wasn't the case for us. Therefore, with double quotes, our internal implementation, so the customer implementation. The idea though was, that's why double quotes, because it is still based on top of the dependency container built by Courier, so we can still foster the alignment with them. We come up with to make it simple, we try to use a property wrapper at dependency to resolve registered dependencies easily. But to do so, we had to use the the service locator pattern. So we had to simply have one dependency container, only one instance across our application. And then we make it compile time safe by building a, still thanks to Paul for mentioning about Sorcery, we use Sorcery to auto-generate a test suite that will scan all the dependency property wrapper usages. We got the unique, and we try to resolve them all in a test suite. If it fails, you got the feedback and you know that you forgot to register your dependency. So, seems good. Let's give it a shot. But let me show you. So simply, as I said, you need to use a property wrapper. You use your property wrapper. Of course, you need to register same way as the dependency container that I showed you before. You use the add dependency. You trust that somewhere is going to be registered, and you get the instances. But the issue is that to get it something so simple, you pay the cost somewhere else. And in this case, you pay the cost in the testing. So still, you need to mock the instances because you got a single container. The thing is that we were having some unit tests that weren't really unit. So it was more complicated than we thought. Therefore, despite some discussion about that, we started migrating. We started to check it out and test. And we really started migrating services from Glovo service container outside. Unit tests weren't that dependent, like I was polling before. There were some unit tests built wrongly using those .default still. So using this, you need to use the setup mocks, not just in the test suite for that component you were moving out, but even everywhere it was used. And even in some tests that you didn't know that was used. So the cost of the migration was skyrocketing, basically. So it was even becoming a risky migration because we were actually almost creating issues on production. Despite we were registering things for some reason, there were some cases where we were having some crashes. And we were realizing when closing the PR, but we were getting those in beta. So therefore, it never reached production, but we are saying, okay, this is becoming risky. We don't feel safe to ship it maybe. And it wasn't that easy to migrate, as I said, for the cost in test. So we were saying, okay, we are quite down now. We tried a little bit of things. We don't know maybe what to do. But we remember now, we got in our values to stay humble. So we got back to it. Okay, let's stay humble. This is the next chapter about humbleness. And what we did, okay, let's get back to the requirement, okay? Compile time safety, easy to use, easy to adopt, and standard DI system at Glovo. What we did is actually thinking maybe we are constraining ourselves too much. Therefore, we said, let's make this one optional. If we can have a standard, the better. If not, let's solve the issues for us first, and then we'll see how it goes. And then we thought, why we are aligning so much with the folks just because they are using iOS? Perhaps there is another app out there, customer Android, that is doing the same thing. It does have a standard. It does have already modules, and it does have already the DI system in place. So we can use that, we can leverage their knowledge. We can foster discussion among the teams to make sure that this is actually can improve our code base, and we can adopt the new DI system faster. Sorry. Okay, with the new set of requirements, we checked then the customer Android. They were using Dagger back in the days, but they migrated to Yield. Actually, today, I want to compliment because they opened the last PR removing Dagger. And what we liked is actually that it is scope-based. And we'll see in a minute what I mean. But actually, you can have multiple scopes, and you can access to the parent scope. So you have a hierarchy of factories. And we thought, okay, this is pretty nice. So let's see what's out there once again, because we don't have time to spend for yet another internal solution. So we check once again the dependencies, and in the end we choose one, and we choose the competitor one. So why the heck you would say no? Using the competitor third-party dependencies? Yes, why not? We were a little bit off, no, a little bit of contradiction, but why not? The thing is that if you imagine, I get it too far. Okay, if you imagine Uber, no, delivering their foods for their Uber Eats, and being this car actually being Needle, so their tech, and imagine this car being parked on a street, and you find that there are already the keys inside. You jump on it like GTA. You get a car to deliver your food. So why not, no? Leveraging their tech to do our own business. Why not? So to do this, it seems easy, but it actually is a shift of mindset, no? Because actually we got ego. We want to build our own solution. We want to be cool. But actually we need to accept sometimes that we are not, depending on the priorities, the business, whatever we have, depending on the cases, we need to make business sensitive decision. And in this case, why not? We drop our ego. Okay, let me talk you through Needle then. They claim to have high reliability, therefore compile time safety. Their code generation they use to actually make the code compile time safe is highly performant. It seems to be compatible with whatever iOS application is out there, and it's similar to Dagger Yield. So it will be fostering alignment with customer Android. Okay, let's see. Okay, this is the example that I took from their README. So simply, you have a dependency. So this is not really a dependency. They call it a dependency Needle. You just define a protocol of their dependencies. And this is, you need to imagine this as encapsulating from the parent to the child. You are asking to the parent what you need from the parent. So you know that there are 2 food, chocolate and milk, coming from the parent, and you need only those. Maybe on top there are multiple. So you just specify this for your component, the Needle component. And actually, it's a simple needle component. You specify your my dependencies. And in this case, what you can do, you are defining another scope. So you're accessing to the ancestor, you are creating a child of the ancestor. And what you can do is creating properties like hot chocolate that is actually made by two dependencies, chocolate and milk. Or you can create a subscope yourself, like my child component. So you are creating a hierarchy. And those, you can see those basically as factories or provider in Dagger. Okay. Sorry, that's what I said. I forgot to click. Oopsie. Spoilers. Many spoilers. Rodan, are you clicking? Yeah, it's super slow. Yeah, here. No, too much. No. Stop. Problems. Oof. Seriously? No, stop. Okay, we got it. Yes, we got it. Okay, cool. So we built a POC to actually check that it was working for us. We tried to test it out to scale horizontally, vertically for our modularization, if we could match our, our requirements in terms of North Star. And it seems that it was promising. Therefore, thanks to mobile platform that they built for us a process to introduce third-party dependencies, they built a dependency checklist. So before to actually introduce a dependencies like this one, coming from another company, we had to do, as you see from the document from the GIF, we had to go through several steps and make sure that we go through them, set the ownership, we checked the load install size, build time impact, performances in general, many more checks. So it has to pass a difficult, exams. And actually from the impact we saw, to summarize some of them, the binary size increase was negligible, 0.1 megabyte. Measuring the impact with 325 needle components, so a similar scale of Dagger components, Dagger module that we're using on a customer Android. The impact on the bug clean build was 10%. And it was actually acceptable speaking with them, because actually at this scale, they were having, like, I don't remember, but I think roughly 15% or 18%. So, okay. And on the clean build in the release one, only 3%. So, okay, pretty acceptable. We were expecting some cost, and this is the cost. Okay. And this is our DI hierarchy. This is actually the true hierarchy that we built in customer. As you can see, those are our scopes. The first one is the app module. So it's the root of the tree, representing the app. And then we got our module. We're going to be having a component for each one of the module. And then if you need to scale further vertically, you can have, if you have multiple features in your module, you can have a feature, multiple feature for your module. And those are actually needle component. But to see how we glue them, like we saw in the example, like with the dependency, checking from the communication between the app module and this child customer foundation, we may have a simple variable property, CDN service settings, that we, for some reason, we exposed there. As you can see, the Bootstrap component is their root component for the tree. That's how they know it. You have that property, and you know that wherever you want in the sub layer, in the subscope, you can get it. To get it, you need to specify your module dependencies as this one for customer foundation. So you say exactly the same property name, the same property type, and you will gonna get it. And in your module, actually in the needle component representing your module, so in this case, customer foundation, you specify the dependency, so the input you're gonna be getting from the parent scope. And then you can instantiate your image service, in this case, the one we use for downloading images behind the CDN. And you set the shared. Shared means singleton. So it's going to be available for the whole life cycle. You instantiate it once and that's it. And you use the dependency. So you can use auto completion from Xcode, CDN service settings, that's my dependency. You inject it. But there is another way. This image service should be used across our module, because every module may be having the need of downloading images. So in this case, let's see the communication between two modules, and they need to communicate through, in this case, the root or any common ancestor they have. And this is done in the other way around. So we saw already the image service being instantiated here. In this case, we are exposing the output from the module, from the factory actually, with a protocol. So it's a simple protocol exposing what you need to expose to the outside. So image service for that protocol. In the app module, we know each child. Those are going to be defined like this. In this case, we are still using one instance for each one of the module. So you're having customer foundation, checkout, and you set the parent. By setting the parent, you create the hierarchy. And here you got the channel for communicating. And then on the other end, you just need to specify the dependency for the checkout module. And instead of passing the image service, because we need to, otherwise we need to add boilerplate code on the app module, we just get a module. And this is way simpler, and those interfaces are super small. The cost you pay is here. So you need to know where actually the image service is. But we are fine with this. We can pay this price for now. So in this example, in the checkout module, you got from the dependency, you get from the dependency protocol you specify, you're going to be getting the image service, knowing that it's within the customer foundation module. And this is in this way you instantiate easily your view model. But what's the plan to actually migrate to Needle? The plan was, as soon as we chose to go with Needle, after all the checks we did, was to stop adopting the dependency property wrapper. We started already migrating, stop it right away as soon as we chose. Remove the already registered dependencies with the property wrapper. And then as a next step, migrate the services and the app services to Needle and provide the guidelines for everybody to have the know-how to do the same thing if they want to contribute. And third step would be actually migrating the feature and helping the feature teams migrating them, slowly migrating them iteratively, and measure this adoption. And we use Sourcegraph to do so. But what's the status of the plan right now? Right now, we stopped the adoption, of course. We remove not all of them, but the majority of the registered instances. As you see, we were using 100 and something occurrences. We got closer to 0. We migrated a little bit more than half of services quite easily. We need to still migrate the app services to Needle. But we provided guidelines, extensive guidelines, hopefully. And we started migrating few features with what we have already. And we are ready to measure the adoption with Sourcegraph, as I said. So we can see actually what we were using by injecting the service container directly from the constructor to Needle that's starting to be adopted. And actually, that's it. Any question? I need to keep it.
So any questions? Yeah.
Uh-huh. Expecting that, huh?
How do you handle the dependencies between the third parties and with CocoaPods, Twist? I mean, because you need to bring these defined protocols from one place to another, some on a repo.
I don't know if I got your question. What do you mean, those protocol?
Yeah, I mean, you will need to expose these protocols to other models.
Okay. Yeah, I need to give you a little bit of context then. In Glovo, in our modularization, we have implementation and API modules. And actually, those are pods. We put the protocols in the API. Therefore, in your implementation, other implementation module, you all import the API. And that's in this way, we avoid looping and we know what to import, just the API. So we got the separation between API module and implementation module. I don't know if I answered your question or was it okay?
Anybody else? Any more hands? No, okay, well.
Yeah. It is in the plan to put this on the Courier app. I mean, why not?
That's a good one. No, so far not. No, that's why we chose to not have this constraint. So we go free so far in the two apps. We have different needs, but roads may cross at some point and we may align. Who knows? Maybe we go back to dependency container. I don't know. But so far, no, we don't have plan to align.
We should do internal talks before doing public talks.
Yes. Yes, sure.
Here.
Mike.
Thanks. Actually, we talk about this in the dry run today. It's like both applications have different needs when it comes to dependencies. So the use case of a user that actually has the Courier application open They usually have it open for 1-2 hours continuously because they are all the time working on it, and they have one single instance of the app and they are just focused on that. While the use case for a customer that's going into the application and it's navigating through lots of different sections of the app, you are really allocating and allocating much more stuff. So this is actually something that when he said like maybe we should align with the team in Courier in customer Android, it's because they are actually solving a much similar problem that even though we share the same language, we are solving really different challenges and we have different use cases with both applications.
Yeah, but that's a good question. We tried as much as we can, but in the end, we choose to align with the more similar, the SPY still is the guy beyond the river, is the folks beyond the river Android, but still they're doing the same thing. So why not? Good point, David.
Talking about Android.
Ah.
No, because it's something that we usually don't see in meetups. Like you say, okay, I went to the Android folks that are doing exactly the same app that I'm doing, and I got inspiration from them. And of course, for Android, it can be the same to iOS. So you have more examples of cross collaboration between platforms, even if it's not just DI.
Yeah. As soon as we started, we saw, at least in the core team, a lot more chit chat about it. We actually checked the Dagger module, now the Hilt. So we check the code base first. We try to understand how to align, and we do the same thing. But I am really curious to see how it's going to be developed in the future for future teams. So as soon as they're going to be adopting the Needle more, our solution, we'll see how it goes. I'm really curious. But so far in our team, I see a lot more collaboration, and that's what we want. Maybe it's
Right.
your turn,
Yeah.
Yeah.
So, no more
I have a question, a last question.
Oh, sorry. Go ahead.
It's because it's concerning me. I am thinking, but you are not creating coupling between models.
Sorry?
You are not creating with this solution as the solution you have proposed when you have talked about the milk stuff and so on, chocolate or something like that. You are not creating some kind of coupling. That means that one model needs to know what already some kind of other model already exists. The thing that I am thinking is it is possible to be more abstract? Can you, instead to tell the system, hey, you need to go to the dependency reference, I passed you a protocol or something like that, and you figure out how to solve the problem?
Absolutely. As I said, you may pay the cost in the image service case. You may only know that there is an image service around, and you need to get it. But you need to write manually boilerplate code in the app in the top layer. So you need to be. We decided to pay this cost so far because we don't want to be adding a lot of code on the parent scope just for syntactic sugar. So, but yes, actually, you need to know that the model exists with a given name, and that's it. And so far, it's working.
Yeah,
but if you put it in the API and you have a protocol for it, you may call it provider. You may not know that it's a module. You may have multiple protocols exposing different things. You segregate the interface, and that's it. So you don't have any issue with that.
Okay, thanks.
But if we want, we can talk more.
Okay, so I want to just do something a little bit for fun. So first of all, hands up here, who is like writing code that deals with dependency injection, or it's potentially an issue? How many? Why, kind of most of you, really. So what I wanted to just do is a kind of quick quiz, right? Well, it's not really a quiz, it's just a vote. So I've got some names here of different dependency injection frameworks. Now, before we get there, first of all, no framework, just constructor or property injection. Who votes? Somebody keep count of votes, please. Yeah, count. No, you have to. It have to be. Yeah, I no. Okay, come on.
Biased.
All right. So how many votes is that? Do you want to count? Who's keeping a count?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right?
Okay.
I guess 10
Yeah.
plus you 11.
Okay. So, okay. What about Swinject? How many votes? Swinject. Yeah, no, just, you can stick your hand up. more dominantly like that, you know. Okay, there's two. Okay,
Okay.
Swinject. All right. Cleanse. Anyone come across that? Cleanse? No? Zero? All right. Okay. Sorry? Sorry, what? Prefer, yeah, what do you want to use? Yeah. So now, next. Okay, we have today's conversation. Needle, how many votes for needle? I mean, yeah, it's a very loaded question here. I know, obviously the audience, 1, 2, 3, 4, 5. All right, okay, hang on. There's another one called Weaver, which I have never heard of before. So anyone use that? No. Okay. Weaver. Factory. You've heard of Factory?
It's actually pretty similar implementation of Courier.
Yeah. Okay, and then what about just property wrapper? Inject, yeah. No noises, just hands, please. Yeah, 2, all right. Okay, so, and then, just be really controversial. So you've heard of point free. And they're point free. You can't have multiple votes for the same thing. It has to be, you know. So point free also have their recently published their library for managing dependencies. And I can say that my personal opinion is it's really interesting how they actually deal with this, because they consider things like date as a dependency, the current time as a dependency. Not just any external dependencies, actually even system dependencies on things that you might be using. And so they make it really easy to use all of that and to make it a very determined state on anything that you want to do. And it's a really good approach. I mean, obviously, I'm just voicing my opinion on this. But have any of you actually tried it out? You've done everything.
Just checked.
Yeah.
Check it out. Yes.
Yeah. So yeah, nobody's like voting for it. No, you've already voted already. Remember? No. Okay. So, so I think that at the moment, constructor injection, keeping it simple, is pretty much the most popular vote.
Mhm.
Yeah. So you didn't convince them. I'm sorry.
I know.
Yeah.
But it was the lag. It was the lag
Yeah.
of the remote, you know.
Well, okay, so I'm going to wrap up now. So thank you very much, all of you, for being here today. And we, one thing. Are you in our Slack group, NSBarcelona Slack group? If you are not, come to me afterwards and I can just add you in, right? It's a very low noise group. It's just so you know what's going on and about events and so on. At the moment, the biggest thing that we're looking forward to is, of course, what's happening on the 5th of June, the next WWDC. We were talking about having somebody hosting, but nobody's actually volunteered at all. So I don't know if anybody wants to think about that. What? Sorry? Oh, it's a holiday. Oh. Yeah, that's not going to happen. No. Oh, well then, what can I say? Yeah. We'll have to do our, our keynote bingo at home, no? Exactly. About how many times did they say this the most, what are the key catchphrases? The most amazing, awesome, they don't say awesome, sorry? Yeah, most performing, our best computer yet. They said it every year because it always is. Yeah, obviously. One more thing. Well, I don't have any one more thing today. Anyway, I'm just going to wrap up. So thank you very much again. Thank you to Glovo. A big round of applause to our presenters today, to Paul and Lorenzo. And hopefully we will have another event next month. One last thing, actually, I just like because I was going to say something before and I just remembered. So have any of you about to launch an app? And one hand up, I know. Yeah. You're going to launch something as well. Do you want to say anything about it? Ah, okay. And yours? Security camera. Oh, yeah, that's right. When's your launch date?
Yeah, so I'm setting up the company here in Spain, and it's been 4 weeks already, and I'm just
Mhm.
waiting for the paperwork to finish. So yeah, as soon as it's finished, I'll launch it, and maybe at the next meetup I can do a lightning
Yeah,
talk.
exactly. I hope so.
Yeah. Cool.
Okay, thank you very much, everybody. Right.
One more thing on top of this, if you can scan this QR code and give us a feedback, it would be awesome for the satisfaction factor. It is, how good the event it was, so we can improve. It's actually took a minute, and that's it. Thank you.
There is some spare pizza, so if you want to grab some last slices over there, feel free.
La mia felicitazione per te, amico.